we are going to start the first lesson with chapter 3, which is matrix. Listen very carefully. It's a very interesting and very simple topic. Matrix. This is the topic which you have also studied in class 10 standard. So we have some idea about matrix. This matrix is a rectangular way of arranging the data. We call it as a rectangular array of data. Rectangular method of arranging data is called as matrix. We have so many ways of arranging the data. Basically, in statistics chapter, we study about bar graph, pie graph, histogram, broken line graph. There are so many. All these are different ways of arranging the data. So sometimes we draw the column and we represent the data. Sometimes we use a circle, we call it as pie chart, and we represent the data. This is a different method of arranging the data. Here the data are arranged in the form of a rectangle. We call it as matrix. We call it as matrix. So rectangular method of arranging data is called as matrix. Clear? Matrix is the singular form, and the plural form of this is matrices. Is matrices. Is it okay? Now when you write a matrix, we write in the form of rows and the columns. Clear? So first of all, the matrix is how we define is rectangular method of arranging data. This is called as matrix. Clear? If I give you an example of a matrix, A11, A12, A13, A21, A22, A23. This is example of a matrix. This is one of the matrix where the data A, all these that you see here are all the elements of this matrix. We call them as element of the matrix or the members of this matrix. Clear? We will have matrices of different size. Matrices of different size. Size means the number of rows and the number of columns. The size of a matrix is described in terms of number of rows and the number of columns. The number of horizontal lines are called as rows and the number of vertical lines are called as columns. Is it okay? Yes. So when we describe the size of a matrix, we always describe it in terms of rows and the number of columns. First we write the number of rows and then we write the number of columns. So if you see this matrix, then we have two number of horizontal lines. That means there are two number of rows. And first we write the number of rows. So the size of this matrix, the number of rows in this matrix is 2. And then we have number of, now we will describe the number of columns. And the number of column is the number of vertical lines. So there are 3 vertical lines. That means there are 3 number of columns. So we will write this as into 3. And this gives you the size of the matrix. This is how we describe the size of matrix. Is it very clear? Yes. One precaution we have to take is this sign of multiplication is not an operational sign. Is not an operational sign. Don't assume it to multiply. This is not to multiply. This is just to show or to describe the size of this matrix is 2 by 3 because by stands for multiplication. Is it very clear? Yes. So this is the size of the matrix. This is the matrix. Now in this matrix, I could have written these elements as A, B, C, D, E, F, G, H also. Anything I can write as the element. Maybe 1, 2, 3, 4, 5, 6 also. But there is a certain reason of writing. There is certain purpose of writing the element in this form. Because not only the element, but also I want to explain you how do we describe the position of an element in a matrix. How to describe the positioning of an element in the matrix. What is the position of this element in the matrix? So by seeing this number, we will be able to describe the position of element. Clear? Because this talks about the number of rows and the number of columns. The first number speaks to you about the number of rows, and the second number talks to you about the number of columns. So from this number we will be able to know the position of that element. So this element is in the first row and in the second column. You will agree with me what I said.
Yes,
so it's easy to describe the position of the element. Clear? In the form of notation, when we write this, here I wrote this position in the form of number for you to understand it more easily. Is it very clear?
Yes,
but we have a general notation of writing this position, and that general notation is Aij. This is the general form of writing the position of any element, where the first letter I stands for rows and the second letter J stands for number of columns. How we got?
Yes.
Is it very clear?
Yes.
So in all this now we will be able to see what is the value of I and what is the value of J. I is for number of rows, J stands for number of columns. So the position of this one is, this element is in the second row and in the second row. This element is in the second row and in the third row. Is it very clear?
Yes, sir.
So we have seen two things so far. One is what is the definition of matrix. It is the rectangular method of arranging the data, and another is the nomenclature of the element, writing the name of the position of the element and the general notation of the position for any element, A, I, G. With the help of this, we will now go to the next topic, interesting topic, that is how to construct a matrix of a given size. If I tell you to write a matrix of the order 2 by 2, if I ask you to give me an example, forget about the construction. If I tell you to give me an example of a matrix of the order 2 by 2, very easily everybody can give. You can think of any element in that matrix, because I didn't tell you any condition. I just told you to give me an example of a matrix of 2 by 2 order. You can put any element, inky monkey ponky. You can write 4 different names. If I say to give me the matrix of order 2 by 2, you need any 4 element. 2 by 2 means the number of element will be 4. So you can have any 4 element, because I didn't tell you what element. So you have freedom. You can put any 4 things in 4 different positions, and you can say, sir, this is the matrix of the order 2 by 2. Is this okay or not?
Yes, sir.
I can ask you to give me an example of matrix of the order 3 by 2, 4 by 2, 3 by 4, any matrix, isn't it?
Yes.
But if I don't tell you the condition, then you are very comfortable. You can write any picture or any number or any letter as the element. I wrote the element of this matrix because there was no condition, so I had freedom. I wrote it as A. I can write the same element also. I can write the same figure as the element. Is this okay?
Yes, sir.
But we have to also learn how to write the matrix or how to construct a matrix under certain conditions. So now we are going to see writing a matrix under certain conditions. Clear? Are you ready?
Yes.
This is the question. We are going to write a matrix of the order 2 by 2. According to the question, we are asked to write a matrix of the order 2 by 2 with this given condition. And I want all of you to understand it very clearly. Please lend your ears. This is the condition which we are going to follow in order to write a matrix of the order 2 by 2. Is it okay? So we are now going to begin constructing the matrix of the order 2 by 2 following this condition. Before I look at this condition, I have to visualize the matrix that I will write, the matrix that I will construct. So I am going to visualize my matrix because the question says that we have to construct a matrix of the order 2 by 2. So what will be the structure, what will be the look of my matrix of the order 2 by 2? When I construct it, it will be somehow like this. So we'll start. Let the matrix, suppose the name of that matrix be A. We can name the matrix as A. This is the matrix which we are going to construct. And it should be of the order 2 by 2. So the matrix will appear somehow like this. A11, A12, A21, A22. The matrix that we are going to construct, we are not constructed, this is just our imagination. This is just an assumption that the matrix that the quotient tells us to construct of the order 2 by 2, when I construct it will somehow appear to be like this. Do you agree with me?
Yes, sir.
So, my matrix which I am going to construct will be somehow like this. Right? In this matrix, I have assumed the elements. Because I can't imagine, I don't know what will be the exact element of this matrix. So, I have just assumed. And these are all the elements of my future matrix. Clear? By any means, if I can know the value of this one, this and this two also, I will write it in this place and then I will get my answer. So when you are asked to do the construction of a matrix, this is what you will do first. Any matrix that you are asked to construct, first of all, you have to assume that matrix. If you are asked to construct a matrix of the order 3 by 2, then you have to create a matrix of the order 3 by 2 in the same way. After this, we will start processing of finding the values of each of this element. And for finding the value of each of these element, we are not going to use this given condition. Is it okay?
Yes, sir.
So, you know that the first element of this is the value of your I, and second number is the value of your J. So first I am going to calculate the value of this one, A11. A11. To find the value of this element, I will use this condition. Clear? Yes. So Bij means A11 is equal to Bij. Is it okay?
Yes.
That means here the value of my I is 1 and the value of J also is 1. So wherever I have I, I'll put the value of I as 1, and wherever I have J, I'll put the value of J as 1, and then we'll calculate. So this will be equal to 1 minus 2 into 1 whole square divided by 2. Is this point very clear?
Yes, sir.
I'm just trying to show you how do we use the condition. First of all, we have assumed the matrix that we are supposed to construct, and then we will try to find the value of each member using the given condition. So this is now the beginning. Am I understood?
Yes, sir.
Now start operation. 2 1s are 2. 1 minus 2 minus 1 square divided by 2. This is equal to 1 over 2, and this became the first element of your future matrix, of this matrix. Give the green signal if you have understood. Clear?
Yes, sir.
Thank you. Now we will go to find the other element one by one. Now we are going to calculate A12. That means now the value of my I will be 1 and the value of my J will be 2. So we will put it in the given condition. So 1 minus 2 into 2 whole square divided by 2. This is 2 to the 4. 1 minus 4 is minus 3. Negative 3 square divided by 2. This will become 9 over 2. We got the second element also?
Yes, sir.
Likewise, we will calculate the other two elements now. Now this is A21 is equal to, this time now the value of my I is 2 and the value of J is 1. So we put in the given condition. So 2 minus 2 into 1 whole square divided by 2. 2 is the 2. 2 minus 2, 0. 0 square means 0. 0 divided by 2 means 0. Very easy, no?
Yes, sir.
Now final, the last element, A22. Here the value of I and J both are 2. So we'll put in the formula. 2 minus 2 into 2 square whole square divided by 2. This is 4 minus 4. 2 minus 4 is minus 2. Minus 2 is square. Minus 2 square divided by 2. This is equal to 4 over 2 is equal to 2. Now you got the value of all your 4 elements, no?
Yes, sir.
So finally we can write the answer. So A is equal to, now the first element is half. Second element is 9 over 2. Third element is 0. Fourth element is 2. This is how the matrix of the order 2 by 2 with the given condition is constructed.
Yes, sir. Yes, sir.
Is it well understood?
Yes, sir.
Thank you. Now, the next topic we have is the types of matrices. Types of matrices. And again, we are already aware of most of the types of matrices that we have done in class 10. So it will not take time and it is not difficult also. Let me have your attention here. Can I begin?
Yes, sir.
The first type we have is rectangular matrix. We call it as rectangular matrix. A matrix which look like a rectangle. What do you mean by that? What do you mean by rectangle? The length is different from breadth.
Yes, sir.
The length is different from breadth. So maybe the number of row is different from the number of column, then such matrix is called as rectangular. Very easy to understand.
Yes, sir.
We can think of a rectangular matrix. Maybe we can say 2 by 3, 3 by 4, 4 by 6, 4 by 5. All these are the example of the rectangular matrix because the number of rows are different from the number of columns. I don't need to give you example, right? Do I need to give example?
No, sir.
So if the number of row is different from number of column, we don't have to see that which one is higher. Any of them can be higher. Maybe sometimes the number of row can be greater. Sometimes the number of column can be greater. But what is the important thing is the difference in the number of rows and the number of column. So if they are different from each other, then that matrix is called as rectangular matrix. Is it clear?
Yes, sir.
Please listen my each and every word, because the next day when I ask you a question, if you do not give me answer, my hand will give you answer. Next thing is row matrix. This row matrix also is a rectangular matrix. This also is a rectangular matrix. But then this is called as a row matrix because then there will be one and only one row. There can be many columns. There can be any number of columns, but then the number of row will be only one. Such matrix is called as row matrix. So row matrix is basically a rectangular matrix. So we can say that all the row matrix is a rectangular matrix, but all the rectangular matrix is not a row matrix. What is the condition for a rectangular matrix to be a row matrix? The condition for a rectangular matrix to be a row matrix is that the number of rows should be 1. Very easy, no?
Yes, sir.
Likewise, another we have is column matrix. This also is a rectangular matrix, and then this is said to be a column matrix if there is only one column. So if the number of column in a rectangular matrix is one and only one, then such rectangular matrix is called as column matrix. Again, we can conclude that all the column matrices can be said to be rectangular matrix, but all the rectangular matrices are not the column matrix. So what is the condition for a rectangular matrix to be a column matrix? The number of columns should be 1. All these three are very easy, no?
Yes, sir.
I don't have to explain you also what is a square matrix, because you are very clear with what is a square.
Yes, sir.
Geometrically, we know that all the four sides are equal, then the shape is said to be quadrilateral, is said to be a square. Isn't it? So in case of matrix, if the number of row is same as the number of column, then they can be said to be a square matrix. So maybe the square matrices of the order 2 by 2, 3 by 3, 4 by 4, 5 by 5, all these are the example of square matrices because the number of rows are same as number of columns. Do I have permission to move to the next?
Yes, sir.
Diagonal matrix. Up to this level is very easy. We knew from before also.
Yes, sir.
All of you knew from before. But from here now you have to listen carefully. Very easy. Very easy, same easy as this. Diagonal matrix is a square matrix. Diagonal matrix is always a square matrix. A square matrix in which element along the diagonal can be a non-zero number. Am I understood? I repeat. A square matrix in which element along diagonal is any non-zero number. Any non-zero number. That means 0 is not allowed to be in the diagonal. Other than 0, you can have any number. You can have inky, monkey, ponky. 1, 2, 3, 4, plus positive number, negative number, any number you can have along one diagonal. Along diagonal, you need to have non-zero number. Rest, all the elements have to be 0. A square matrix in which element along the diagonal is a non-zero number and remaining all the elements are 0, such matrix is called as diagonal matrix. Is this definition clear?
Yes, sir.
A square matrix in which element along the diagonal is a non-zero number and all the elements are 0, such matrix is called as
Diagonal matrix.
diagonal matrix. Clear?
Yes, sir.
I don't need to show you the picture, right? Scalar matrix, a close relative of diagonal, very close relative. Scalar matrix is a square matrix. Scalar matrix is again a square matrix in which element along the diagonal are all same and remaining all the elements are 0. Then such matrix is called as scalar matrix. Do I need to repeat? Do I need to repeat? Fine. A square matrix in which element along the diagonal are all same or equal. Remaining all the elements are 0. Such a square matrix is called as scalar matrix. Is it clear now?
Yes, sir.
Is it clear now?
Yes, sir.
Yes, sir. Unit matrix. This also is a square matrix. This also is a square matrix. A matrix in which element along the diagonal is 1. The element along the diagonal should be only
1.
figure 1. 1, 1, 1. No any other element. The element along the diagonal has to be 1, 1, 1. Clear? A square matrix in which element along the diagonal is only 1, remaining all the elements are 0, such matrix is called as unit matrix. Is it very clear?
Yes.
And this unit matrix can be represented by a capital letter I. For other matrices, we don't have any notation, but only we have notation for the unit matrix. It can be denoted as capital I. Suppose if you have a square, if you have a unit matrix of the order 2 by 2, then we can write in shortcut I2. I means unit matrix. 2 means the size of the matrix is 2 by 2. You don't need to write 2 by 2. You just write 2. I2 at the base. It gives you the size of that matrix. I3 means unit matrix of the order 3 by 3. I4 unit matrix of the order 4 by 4. Am I understood?
Yes, sir.
Submatrix. This will come later also. Okay. This word we are not using very frequently. This type of matrix is not